let's continue with division. As I mentioned, basically we are going to try to solve this division. We already started in the previous video. So the first thing, remember, step 0, breathe. So relax, try to remember. Step number 1, try to simplify. We have many zeros, so we are going to try to simplify, simplifying all these zeros, expressing in scientific notation. Okay, so in this case, we can see that we have a negative powers. So if we use the inverse ruler of powers of 10, we are going to have negatives. Minus 3, 6, 9, minus 10, minus 11. Now, let's try to identify any prefix. So we have nanometers. So nano is the prefix associated to times 10 to the negative 9, and the unit meters. So we have seconds there. We close our parentheses. Let's try for the second number. We have another small number. Let's try to simplify, expressing in scientific notation. 3.2 times 10. In that direction, you remember the inverse ruler of powers of 10. We are going to have a negative power. So it's going to be minus 3, minus 6, 7a, minus a. Oh, and I forgot that number 1 that we have also there. Now, let's try to identify if we have any prefix. Kilometers, Kelvin. So, kilo is times 10 to the positive 3 meter, and we have capital K, Kelvin. Okay, this looks more simple, this numerator, than this numerator. Let's try for the denominator. In the denominator, we can detect that we have already in scientific notation, and we have meters to the negative 1 power. You can keep this one in that way, or only to refresh your mind, is the same like express 1 over m. Don't forget that we have a power outside. So this is basically ready to be working with the power. That is the next part. The next term we can simplify, expressing again all the excess of zeros in scientific notation. 9.88 times 10 minus 3 minus 6 minus 7. And we have a prefix and a unit and a power. So we need to be very careful. If you remember the previous videos, so whenever we have a prefix and a unit, and also the unit has a power, we have hidden some parentheses. So we have centiseconds square. Still, it looks really ugly. Let's see if we can try to simplify a little bit more. Let's start with the first term in the numerator. So we are going to have that is an integer and a fraction. If you remember, we can move in front. So we are going to have a multiplication with base 10. Oops, sorry, this is 11 times 10 to the negative 9, and we have the units meters per second. Okay. In the next part is exactly the same. So we have 3.21 times 10 negative a times 10 to the power, and we have meters per Kelvin. Let's try with the first term in the denominator. First term in the denominator is going to give me, it's already in scientific notation, the basic units in the international system. So we start to pay attention to the powers. We cannot multiply yet until we get rid of this power. So this is going to affect to the number, to the power of 10, and the units. 6.3 to the third power, so it's going to be 10 to the 9 to the third power, and 1 over m to the third power. Okay, now for the second term, this is already simple. 9.88 times 10 to the negative 7, and we need to pay attention to this prefix centi. We already have the parentheses, so we don't need to worry about something else. And centi is expressed for the power of 10 negative 2 seconds, and we have second power there plus our parentheses. Let's continue with the simplification, step number 1. So powers and powers we add, if you remember. So 7.1 times 10 minus 11 plus minus 9 is minus 9, and we have meters per second. Little by little you are going to see that this is going to look smaller and smaller. Multiplication with the same base, we add the powers, minus 8 plus 3, and we have meters per Kelvin. Let's try now the terms on the denominators. 6.3 to the third power is going to be 250.047. Now, powers and powers, if you remember, in the diagonal we multiply, so it's going to be times 10, 9 times 3. The same is going to happen for the units, so it's 1 to the third power meters to the third power. Okay, let's try with the second term. We have 9.88 times 10 to the negative 7 power, and we go from inside to outside. Powers and powers we multiply, times 10 to the negative 2 times 2 seconds is 1 times 2. Okay, let's try again the terms in the numerator. 7.1 times 10 minus 11 minus 9 minus 20 meters per second. This is sun speed. In this one we have 3.21 times 10 minus 8 plus 3, so negative 5 meters per Kelvin. Let's see, in my denominator I have 250.047 times 10 to the 27 power. 1 times 1 times 1 is 1, so meters to the cubic is meters cubic. This term is almost done also. What about this? 9.88 times 10, let's see, minus 7 times 10, we have multiplication of powers, minus 2 times 2, minus 4. And we have 1 times 2, 2. Let's keep working. Remember, we need to work like to have different problems inside every single parenthesis. So this is already scientific notation, the most basic units in the international system. Scientific notation, the most basic units. So we can start to apply the next multiplication. You can make groups, numbers with numbers, powers with powers, and units with units, or use your calculator to multiply 7.1 times 10 to the minus 20 times 3.21 times 10 to the minus 5. And at the end, multiply manually your units. I'm going to make the groups 7.1 times 3.21 minus 20, and we know that is minus 5. We have multiplication with the same base, we add. Finally, meters seconds times meters Kelvin. Let's see. In this one, apparently we have an expression of power of 10. We can simplify more to scientific notation. Remember, scientific notation, we express only one significant figure to the left of the decimal point. So I'm going to move 2 positions to the left. Using the inverse ruler of powers, you are going to see that this is going to be from 27, 28, 29 meters cubic, 1 over meter cubic. For the second term, we have multiplication with the same base. We are going to add, so 9.88 times 10 minus 7 plus minus 4 is minus 4, and we have seconds squared. Let's keep writing the division. Okay, let's see. 7.1 times 3.21 is going to be 22.791. We have a number. Positive times negative, negative, minus 20 minus 5 minus 25. And multiplication of fractions. Remember, numerator times numerator, denominator times denominator. And also we have the same base. So we can have meters 1 plus 1 in the new numerator, and seconds times Kelvin, or seconds Kelvin. Let's see. In the denominator, we already have 2.50047 times 10 to the 29. You can keep like that, or how we start with the negative. Meters to the negative 3. It's only to try to simplify, to have everything in the numerator. This one we have 9.88 times 10 minus 7 minus 4 is going to be minus 11. We have seconds squared. Okay, I'm going to try to move the paper so we can keep track of what we have done here. Okay, this is going to be equal. We have numerator. I have my decimal point associated to this position. If you remember the inverse ruler of powers of 10, we have 0, minus 1, minus 2, we have minus 25. If I'm planning to move to the left, I'm going to have minus 24. So 2.2791 times 10 to the minus 24 meters squared, seconds Kelvin. This expression is more simple than the initial one that we have at the top. We have scientific notation and the most basic units in the international system. Let's try to do something similar here. We already have from the denominator scientific notation and the most basic units. Scientific notation and the most basic units. So we can go to the next operator, multiplication. We can make groups, numbers with numbers, powers with powers, powers of 10 and powers of 10, and units with units. 2.50047 times 9.88. Now, For powers of 10, 29. And we have times 10 to the minus 11. Finally, units with units. Meters minus 30 seconds square. Let's solve that multiplication. And the numerator basically is waiting for the denominator to be ready. Meter square, seconds, Kelvin. So 2.50047 times 9.88 going to give me 24.7046, and I'm going to cut here, so it's going to be approximate times 10. Let's see, 29 minus 11, we are going to have 18, positive 18. Now my units, we are going to have meters to the minus 30 second square, or you can express second square divided meters cubic. The only thing that I'm doing here, remember, negative powers means that if you are in the numerator, you have to be this unit in the denominator, or this base. If you are in the denominator, you can move to the numerator with a positive power. Okay, what else? This expression is right now an expression of powers of 10, so we can move our decimal point one more time. So I'm going to keep this like this. Approximately 2.2791 times 10 to the negative 24. We have meters square per seconds Kelvin, and this is 2.47046 times 10. I am moving my decimal point to the left, so if you remember, we have 18 here. If I move in that direction, it's going to be 19. So 18, 19 power. And we have the units, second square per meter cubic. Let's see. Some of you are going to try to cancel. Be very careful. Remember that we are going to use sandwich right now. It's part of the division that we are learning, so be prepared to use sandwich. Let's see, 2.2 divided 2.4 is going to be 0.9 or something like that. 2.27991 divided 2.47046. It's not even necessary to keep using number. So we are going to have 0.9225. We have more digits. I'm going to keep until 4. But remember, we already have an approximation. From here we start to carry one error. Times 10. Division with the same base we subtract. Minus 24 minus 19. And division with 4 terms we apply sandwich. So we have meters squared times meters cubic divided seconds Kelvin times seconds square. We are going to keep simplifying. 0.92254 times 10 to the negative 43. We have the same base, multiplication, we have to add. Meters, 2 plus 3 is 5. Now, we have the same base here in multiplication, 1 and 2. So we can express like seconds cubic Kelvin. Our expression is a powers of 10, and we have the most simple units in the international system. We can do one more step. Move our decimal point until we have scientific notation. we are already in a negative power, so we are in this part, completely to the right. If we move my decimal point one more part to the right, it's going to be more negative, 44. And we have meters to the fifth power, second to the third power, Kelvin. That will be our answer. Divisions can look like to be so big, but in reality it's only part of the procedure that we have been done. Follow the steps, simplify, and it's not going to be a problem at all. Let's try one more division before we finish this exercise. Remember step 0. Just have control on yourself all the time. This is going to help you a lot. Breathe, relax. Let's try to find a big division again. 153 0 0 0 0 0 0 0 0 0 0 0 0 0 0 times 10 to the 20 picokelvin per meter times 0.000 0.0000321, and the units it's going to be a little hard to see, but let's use kilometers per Kelvin. Here at the denominator, let's try 6.3 times 10 to the 9 meters to the minus 1 square. And here something like 9.88 times 10 to the third power of seconds. Again, our step 0 will be relax, simplify. So, whenever we have many zeros, simplify. It's going to be up to you if you want to start to count from here or start to use the hidden decimal point position. I'm going to start from here. Express this number in scientific notation. 1.53 times 10. I'm going to have in this direction the measure ruler is going to be increasing. So 23, 26, 29, 32, 35, 37. So it's going to be a very big number that we have to handle there, and it's not impossible. What else? Let's be sure. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37. Perfect. Now, prefix. We don't have power, so it's only substitute that. Times 10. Pico is negative 12. Kelvin, and we have meter. Let's try now with the second term. Scientific notation is going to give me 3.21. In that direction we have negative power, so it's minus 3, minus 6, if I want minus 9, but I'm going to put here 6, 7, 8 times 10 to the negative a. Now, prefix, I have kilometers per Kelvin. Sorry for that, I have very short space. So, kilo times 10 to the third power, we have meter Kelvin. This is more simple than this. Let's see. Basically, we have multiplication of fractions. The numerator affect only to the integers, so we can think. In this one is the same. Let's try for the second part. In the second part, we already have scientific notation and the basic units, so we can go directly for the next. It's not possible to have multiplication. We have a power there. So this power affects the number to the power of 10 and to the units. And this is basically already weighting. 9.88 times 10 to the third power seconds. Let's try to keep simplifying. Okay, we have 1.53 times 10 powers and powers and multiplications. We add the exponent 37 minus 12. It's going to give me 25. I have Kelvin per meter. So we already found the most simple expression of all this big quantity. Let's try for the second expression in the numerator. 3.21 times 10 multiplications with the same base, we add the exponents. So minus 8 plus 3, 5 meters Kelvin. Let's see for the denominator. So we have 6.3 times 6.3, or 6.3 squared. That is 39.69. Powers with powers, we multiply. 9 times 2. Here we are going to have the same. Minus 1 times 2. And the second term of the denominator is weighting. 9.88 times 10 to the third power seconds. Let's return to numerator. Scientific notation, the basic units. Scientific notation, the basic unit. Okay, we can go for the next step. Numbers times numbers, powers with powers, and units with units. I'm going to make the group 1.53 times 3.21. Remember that you can introduce in your calculator all this quantity using the special buttons times all this quantity and only solve this little fraction manually. Because we have multiplication with the same base, we are going to add the exponent 25 and 5. Now we have the units Kelvin meters times meters per Kelvin. What about here? In this one, we need to write 39.69 times 10, 9 times 2, 18. And we have meters minus 1 times 2